The central processing unit, or CPU, is like the engine in your car or the brain in your skull, and is like a really fancy calculator used to run the applications on your computer. When you write software in a language like JavaScript or Python, you're actually writing a set of instructions that will be executed as machine code by a CPU, which itself is a carefully crafted piece of metal and silicon that contains billions of tiny transistors, or on-off switches that represent ones and zeros. To perform mathematical calculations, a CPU will combine multiple transistors together to form logic gates. For example, AND will take two binary inputs and validate that both are true to produce a true output. Computational problems. Modern chips contain billions of transistors, and they can be flipped on and off billions of times per second. In general, the more times the clock can pulse per second, the faster the CPU can compute, and is normally measured in gigahertz. Now, in order to run applications, it interacts with the system memory, or RAM, in a series of 4 steps known as the machine or instruction cycle. The CPU has registers to temporarily store the address in memory that it wants to interact with. Then the control unit sends out a signal to copy the data from that address to the instruction register, at which point it needs to figure out how to use this instruction. Most importantly, the opcode contains the instruction, like add or subtract, and the operand is the address in memory to perform that operation on. The final execute stage takes the decoded information and passes it as electrical signals to the relevant parts of the CPU. The arithmetic logic unit, or ALU, can perform math on the data and then store the results in RAM to change the state of the program if you're a developer. And that's why I've invited Alex from the most underrated tech channel on YouTube to break down some more advanced concepts like Apple Silicon and how to run performance benchmarking on your own machine. It only takes a few basic logic gates to solve highly complex. The state of the CPU is synchronized by an oscillator known as the clock generator. Gamers will sometimes overclock their CPUs to gain more performance at the cost of higher temperatures and a lower life expectancy. Step 1 is the fetch phase. Think of a software program as a set of instructions stored in the RAM. The program counter starts at 0 and copies that address to the memory address register in the decode phase. The control unit parses the actual bits in the instruction. The cycle is repeated billions of times per second, and modern chips utilize multiple CPU cores to run multiple computations in parallel. That's how a CPU works under the hood, but there's a lot more you should know about processor architectures